connecting the cloud server. Right, so we are now recording, and I'll cut out whatever happens. So Klaus, do you want to switch off your microphone and your speaker?
Yeah, will do.
I'm going to do mine as well.
Okay, off, and here goes my microphone. Bye-bye for now.
Bye.
Bye now. So what's going to happen, you'll be able to hear me. Chelsea, your microphone's still up, isn't it? There we go, you're off. So according to my watch, we've got about a minute left. So in about 30 seconds or so, I'll start broadcasting. I'll also share the screen. We'll see how many attendees we have. And then we'll get it going. Should be good this time. Right, I'm gonna kick it on, and we'll get going in a sec. See how many people join in. Good afternoon, everyone. I can see that our first attendees are joining. Thanks very much for joining in. We just got a minute or so before we get going. Attendees are just coming in as we speak, which is great. Welcome. We're just going to give it a minute or so just to let all the attendees join, and then we'll get underway. Hi, we're just giving it a minute or two for all the attendees to join in, and then we will be getting underway here in a second. Just pull up the first slide. Okay, so it's just after past. I can see that we've got a good number of people who've joined in, which is great. Thanks very much, particularly if you joined in with us on our one previous attempt. Excuse me, we managed to overcome the little issues that we had. We are up and running. Excuse me, and we have Klaus Lange on the line from Sweden, just outside Stockholm. He is going to be running a short presentation for us. And then we will have an opportunity at the end of this to have some questions. A little bit of housekeeping on the system. If you go to full screen view on the window that is on your TV, on your computer, you should be able to get a good full view of the presentation that's coming up. There is an opportunity for questions. If you move your mouse around on the screen, you should get an option to put questions in. We can keep an eye on those questions as we go. So what I'd encourage you to do is, as your questions come up, please just type those in, and we'll address those at the end. And there'll be a general discussion for about 10 or 15 minutes at the end, hopefully generated by a number of questions that you guys have posted on the questions board. So that's hopefully all working, and that you can all see what we're talking about. So before I move on to our guest, Klaus, I just wanted to give a very quick overview of what we at Panther McLeod do for a couple of minutes with regards to underwater robotic cleaning, and then we're going to throw over to Klaus to give a bit more of the history of where they've come from with their underwater robotic cleaning and how they've developed that over the last good number of years, and I'll let Klaus go into the details of the history. From a Panther McLeod point of view, We're in a situation where, as most people know, we historically began as a tank cleaning company with confined space cleaning. Sometimes that was just a routine cleaning and disinfection, but our real unique seller at the very beginning was a chemical cleaning activity for removing iron and manganese biofouling from tanks. And what actually happened was around about 2003, an organization called Vida from Sweden, who have been working in this underwater cleaning arena for a number of years, started to approach the UK market with a view to cleaning in drinking water facilities. And Klaus can give more of that background in a second. And that's when Panther McLeod first came across Klaus and Vida, and we set up a partnership back then, and we've been working with the Vida machines ever since. So we've been doing this for about 15 or 16 years now in the UK, and as you can see here, we're actually not far off our 500th underwater robotic clean in the UK since we started that partnership. What actually happened was the ROV inspections as an underwater capability for the drinking water sector came into play about a year later. Initially, we relied totally on cameras on board, and you'll see in a second the footage shows some onboard videos from the cleaning machine itself. But we found actually over time that working in conjunction with an ROV became much easier in terms of being able to get a view of everything that was going on in and around the cleaning machine. So the ROVs came into play, and of course they now have a role almost more so independently of the cleaning machines, but we do run the two together. So we've got a long background in this. We've done a huge amount of work in this area. We've worked with Vida all the way through this. They've got a much broader portfolio, and we thought it'd be interesting today to hear a little bit more of the broader portfolio, but also potentially in the questions to bring it back to concentrate a little bit, if we can, on drinking water assets, although we do some industrial. So what I wanted to do is just run a short video here that will show a little bit of our underwater robotic activity. What you can see here is a VR600, and you'll hear more about that from Klaus in a minute. This is removing a very fine amount of sediment from the floor of a drinking water tank, and you can see the emphasis here is on zero turbidity. This is another job we did where it was just at a water treatment works where there was a lot of lime and sand that built up in a contact tank that couldn't be taken offline. And as you can see, some of this was pretty deep. We were talking kind of 300 to 400 mil deep in sand and lime on a particular job, and the machine was able to slowly but surely cut through that. Here's another tank. This is routine sediment. I'm still not 100% sure what the gray film on the top of this is, but it's kind of settled out with maybe a light kind of layer of lime on top of some regular organic sediment. This is from a onboard footage on a machine in I think it's quite old footage from a tank associated with a filter where sand had broken through in the filter, and there was a lot of sand deposits in one of the compartments in the treatment plant, and we were using the machine so that the treatment plant wasn't taken offline to remove some of the sand from, well, pretty much all of the sand eventually from this particular treatment works. So here you can see some onboard footage, which is different from some of the other footage we showed where the ROV is flying alongside the cleaning machine, showing that. So as I say, there's a variety of different applications we've been able to use this on. This one here is some industrial work. We also have some separate machines which can run faster where there's not so much of a concern about turbidity. This particular job was for the Commonwealth Games. They converted part of the Scottish Canal system into a canoeing and kayaking event environment. It's still running now as a leisure facility, and we were able to clean that in advance of the Commonwealth Games, so they had a much better environment as they ran the canoes through the whitewater rafting area that they built there. So some industrial work, mostly drinking water work, and as I say, we've been doing this for a long time. So that's the background on Panther McLeod very quickly. I'm keen now to introduce Klaus Lange. He's online. We're actually running a recording of the presentation just so we could avoid some technical issues, but Klaus is with us. We'll run this recording of his presentation, and then we'll be able to take questions over the panel from you guys and discuss that with Klaus for 10-15 minutes at the end of this presentation. So although I'm not doing a kind of live intro to him, he is there, and this is Klaus with his presentation that we pulled together for this. Here we go.
Okay, my name is Klaus Lange. I am the managing director of VEDA. VEDA is an old company. We're celebrating 100 years of business this year. I haven't been with the company all 100 years, but about 25 years. So we have a long experience in the underwater business. Today, VEDA is a privately held company. VEDA was from the beginning a aluminium foundry, one of the largest ones in Sweden, and we got into the pump business through Flygt or Flight, or today they're called Xylem. When they invented the pump, VEDA made all the castings for all the pumps. Eventually, Flight started their own production, and at that time, VEDA decided to make their own pumps. These pumps are still made. They are made in Spain, and they are actually today owned by the Swedish group Atlas Copco. We have the name in common, and that is all, really. We actually let them use the VEDA name because we think it's good marketing for us. The VEDA pumps are, however, used in most of the cleaners that we make today. And again, all our focus is on underwater cleaning. We went from the submersible pumps in the mid-70s when somebody had the idea that you can use a pump to make a manual cleaner for public swimming pools. And very quickly we got into automatic cleaners starting 1981. And I would say that today we are known worldwide for our underwater cleaners for public pools. We have a subsidiary in Germany, completely today focused on the swimming pools, sales and service. And we have also a part of a company in the US. Today we have, I would say, over 2,000 pool cleaners in use on a daily basis worldwide. We started, the company has been owned by several different Swedish groups. We were owned by Bofors, the Swedish company that makes military equipment, and we were owned by the Swedish Electrolux for many years also. In 1991, I bought the company together with a group of people, and we started to look at where our actual expertise is. And of course, the public pool market is a limited market with lots of competition. And a little bit by accident, we got in contact with the Stockholm Water, and we started developing products for the drinking water industry. And maybe the most successful product of these products that we invented together with them was the product that we named the VR600, which is used for cleaning drinking water reservoirs. Of course, with the benefit that you can clean the water reservoirs without any interruption of the supply of water. You don't need the human entry, and it became a very cost-efficient way of cleaning. Today, I would say that we have these machines worldwide, of course, with a few open areas in between. And I would say in most places, this has become an accepted way of cleaning. And of course, also a way of saving lots of water. I brought in the picture you see on the lower end there, and I don't know if you can see it, but on the top of that water tower is one of our operators in Sweden, brave man. So we can clean almost all type of water reservoirs, independent if they are towers, or if they're on ground, or if they're in ground. When we then went out on the markets worldwide and presented our cleaners for the drinking water side, we learned that there are lots of other applications where an underwater cleaner has a function. I've shown a few pictures here. This is from a cooling tower tank in Korea. There are all types of different reservoirs in different type of industries. We have actually a number of cleaners in different zoological gardens around the world. And of course, we want to brag about being the sole supplier to the Olympics in Athens with the pool cleaners. Another area that we came into a little bit by accident was artificial lakes and fountains. And this is a good showpiece, we think. This is 120,000 square meter of water built around the Burj Khalifa in Dubai. And after having built this whole lake and filled it up with water, they had forgotten really how they were going to keep it clean, much to my surprise. This is very close to a desert, and it fills up with sand very quickly. On the right-hand side there, you see a picture of the light blue area, which is what we have cleaned. Actually, this time with a normal swimming pool cleaner. And you see the brown area to the right. Brown area, that's what it looks like after 2-3 days in the lake. Today we have 40 machines running in that lake on a daily basis. So it's close to 20 hours per day. Machines from the smaller pool cleaners for some areas to the largest machines we have ever made, which is a machine with 2 4-horsepower pumps and a 5-meter wide nozzle. This has become, it's been a very good experience for us, and of course it's become a very good showpiece for any client in the Middle East, since the machines are there for watching around the clock. Here is a short video just showing how one of our machines, this is a machine with about a 1.5 meter wide nozzle, takes up the sand, and you can see that the pump is attached, on the pump is attached the discharge hose, and we pump about 200 meters with no extra pumps to a filter system that they have built at the side of the lake. Another type of applications are all sorts of outdoor reservoirs. In this case, it's a reservoir outside Stockholm with a liner, where they take care of toxic waste. And of course, this one fills up in on the bottom, and they have to have a system where they can remove the sediment. In this case, we use one of our larger machines, and in this case, they absolutely wanted us to put the water back into the reservoir after we had cleaned it off. And in this case, we use a flocculator, we use a geotube, we pump everything into the geotube, and we just let the water fall back into the reservoir. We are coming more and more into discussions with filtration, since wherever you go around the world, everyone is very interested, of course, in saving water. Another application that is a bit special are the nuclear applications. And actually the first cleaner that we supplied to industrial use was in the UK to one of the nuclear power stations. This was in 1981. And I had a meeting in Sellafield not too long ago, and there I met one of the older men there, and he told me that they had installed this machine in 1981 and it's still running. Good to know, but not very good for sales of parts. But this has become a good application for us. We also have developed a special machine for cleaning the reactor tanks. And we have done this in cooperation with Westinghouse Electric in Sweden. And of course, they had very, very special demands. And in this case, we are not only cleaning the bottom, but they also wanted us to clean the walls. And this is an example of how the machine works when it cleans on the walls. So they actually drop it down in this reservoir, and it floats, and when we start the pump, it will suck itself onto the wall, and then you can start cleaning. And in this case, the machine is controlled by a remote control. It's a very simple cleaning operation, and when we clean, you can see how clean the walls are. You don't actually see what we're taking off. We're taking off radioactive small aerosols. And the benefit with this is when they have to empty the water to put new power into it, or when they need to do any type of service, the people can go in and work immediately. if we don't clean the walls and the bottom, they have to ventilate this room for about 24 hours. And of course, you understand that it's very costly to have a nuclear power station being idle for 24 hours. So this pays for itself very quickly, this type of machine. Today we have machines in Sweden, France, and in the US, and we are of course looking very much into the Chinese industry. The nuclear industry is, some people think that we are getting rid of nuclear industries, but that's not really the case. I've heard that they are planning for about 100 new nuclear power stations in China. So we want to get into that market, of course. Other types of reservoirs we work with are reservoirs. This is an example of a reservoir in India, where they bring in water from one of the nearby rivers. And you see on the left-hand corner, there is what I call our competition. They bring in children to clean it off after they drained it. Now, using our cleaners, there is no need really to drain it, so they will simplify this. And it's a good solution for them. India is becoming a very interesting market for us. Another one of the products that we developed together with the Stockholm Water was a cleaner for taking off the algae or the schmutzdecke from slow filters. And this is a very similar machine to the ones you saw, for instance, the one you saw at the Burj Khalifa lake, although it has a different kind of a nozzle that digs into the sand a little bit, and we remove the schmutzdecke and a little bit of sand. And we can do this while the slow filter is still in action, again, saving both water and time for the waterworks. This example is from Eau de Paris in France. Here's another new market that we have come into with a similar machine to the one you saw in Burj Khalifa, but a little bit smaller. And here we clean cooling power banks. And of course, this is an important job because it's a very unhealthy area to work in. And we have today sold these type of machines to South Korea and China and some European applications as well. So this is again a growing market for us. Here's another market that is popping up very quickly. I heard that today they are planning for 6 desalination plants only in Israel. And of course, everyone knows that we are running out of water. And these applications are also with machines similar to the one I showed in Burj Khalifa Lake. The main challenge here is that, of course, being in salt water, and we have an application down in Saudi Arabia where the water is also very warm, it's a big challenge to work in these aggressive waters. And we learned that they don't really consider stainless steel to be the safest or best solution. They would rather have regular steel and epoxy paint them. So we found a solution for that as well. Another application is circulating water in all type of steel plants, and this besides of many other type of applications wherever they have water circulating for cleaning or for cooling. Most of the time the water ends up in some type of a reservoir, and if we can come in with our cleaner, we can offer, of course, to do the cleaning without any interruption of the production, which is important for most industries. This is an application I show a little bit more for fun and excitement. Maybe this is in Tasmania, and this is a tank. It's the last tank in a sewage station. It's not very deep, but of course they get some sedimentation there as well, and it used to be cleaned manually. And when we came with our machine, the people became very happy because this reservoir had one problem. There is a lot of snakes in it. I can understand why they don't like to get into that reservoir. I wouldn't even put my toes in there. Another example, unfortunately, a job that we lost due to Mr. Gaddafi was a big job in Libya. This is one of the largest water projects in the world called the Great Man-Made River Project. They found in Libya, that's shown on the map down to the left, they found water in what they refer to as aquifers and water of drinking water quality. So Mr. Gaddafi decided to build a pipeline system. It's about 1,000 kilometers from the aquifer to Tripoli. And they built a pipe system with 3 pipes next to each other with 2-meter diameter all the way up to Tripoli and to Benghazi. And along the way there, they had to build reservoirs, and that's what you see on the upper picture on the left. Huge reservoirs where they needed machines actually just to remove the sand and put it back into the desert on the outside. Unfortunately, we didn't manage to get the order before Gaddafi became a little bit too unpopular. So we have decided to stay away from Libya for a little while. I was down there a couple of times, and I must say the last time I was very happy when I got out. So there are a number of special applications, and I will not go through all of them, but in general, we have probably the broadest product line of underwater cleaners in the world today. And we have, over the 20 years we've been involved in this, we have developed a number of different types of cleaners, and we are very open to discuss all type of applications or wishes from different clients to adopt machines for their special applications. And I mentioned earlier cooling tower tanks, which is a growing market. Of course, the base for very much of what we do besides the public pools is the drinking water side. And that's an area where we feel that we are very well established, and sales. It's not coming by itself, unfortunately, but we have so many references around the world with very large water companies that we feel that it's very easy to convince a new market to have a look and test our products. So we are engineers. We are a group of 10 people here. We are all engineers. We like to develop products, and we have a number of suggestions to develop products for other applications. And you see a few examples, or at least one example to the right. Growth on the hulls of ships becomes very expensive, and we are looking at a solution where we can use our cleaners on the hulls on the ships while they are at port. But we would like very much to do this together with a company that is already in this market, so we will see how that develops. A new thing that have come up in the pool industry is that one is trying to avoid the use of chlorine, and then they are building what they call natural pools, which are pools without any chemicals whatsoever. And of course, the tricky part of that is that there is a lot of algae growth, so they need a lot of cleaning. Good for us. And I really don't know if there are any of those in Germany, in France, Italy, Spain. There are more and more of these pools popping up. They are cheaper to build, but of course they cost a little bit more to maintain. And as far as development, besides the special applications, we are in a situation where a lot of our clients around the world are asking for what everyone refers to as artificial intelligence, cloud-based technologies, solutions where you can run these machines from a far distance, maybe from a computer anywhere in the world. And we are in the midst of a couple of projects to be able to adopt this type of technology to our clients. So over the years, we have built up some very good references around the world. We work very closely with Veolia Water, since they seem to be all over the world, also in the UK. We deal very much with them in China and in the US. Westinghouse, I mentioned before. Sinopec is the former China oil and gas company with hundreds and hundreds of different industries in China, where we have become an authorized supplier. after a little bit of work. Severn Trent is just one example of the water companies that we deal with in the UK. Of course, there are many, and all developed, I would say, through Jim and his people at Panton McLeod, whom we have been working with for many years, and slowly but safely built up a good market for us in the UK. And that is basically what I had to say today. And of course, I'm available for any questions. I hope you have some questions. And thank you very much for your time.
Klaus, thank you very much indeed. And there you are, live as well with us, which is great.
I'm still alive. Yes.
we can do the formal intro, and thank you very much for that. That was as I mentioned before, that was a pre-recorded. I like the fact that you've made the effort to wear the same jumper and arrange the same light from the window so that it looked like.
I washed it in between.
We could make it look like the presentation was actually live, but we fessed up. It was recorded a couple of days ago, just so we could be sure we had it all in the bag, as I say. So, Klaus, there's a good few questions. We've got about 15 minutes left or so, and I just highlight again to folks that there's an opportunity to put in questions in the Q&A box, preferably there. You can use the chat box as well. We're monitoring that at the same time. We've got one question at the moment in there, but a couple of questions in elsewhere. Klaus, these are initially our questions that we probably get quite often, so it'd be interesting to hear your take on that. I'm going to start with one which I can maybe share a video that we used at the beginning to help answer this again. One of the questions is about the maximum depth of sediment that can be tackled with an underwater robotic cleaner. I think we're probably talking about within a potable water, drinking water asset, because obviously with industrials and all the various systems you just highlighted, there's probably differences. But what's your take on the question? What's the maximum depth of sediment that can be tackled?
Yeah, well, it's a question that always comes up, and our experience is that most of the water companies, actually most of the owners of reservoirs, do not really know how much sediment is in the bottom. And I remember one of the first jobs we did, it was in Boston in the US, and they told us there were probably maybe up to a feet of sediment, and it turned out it was 1.5 meters. And we managed to clean that reservoir, but of course it takes an enormous amount of time. So it's very hard to give an exact answer, but I mean, we try for the drinking water industry to have the water companies clean before it builds up more than maybe well, it shouldn't be more than 1 feet. I know you have a lot of experience, Jim, from this also. And since what we normally say is that since we don't create any turbidity in the reservoir, and the company doesn't have to take the reservoir off duty, then it makes sense to clean the reservoirs more frequently than they are used to. I mean, if you run it with the way it looks on the picture here, you can run the machine at full speed. And then we say we normally do 150 up to 200 square meters per hour. If you have half a meter of sediment, then you have to basically stop the machine and let the pump run for a while, then move it a few inches ahead and keep the pump running. You understand what I mean, right?
Yeah, absolutely. And I think what I would add to that, Klaus, is that it very much depends on the type of sediment. So if it's sand, as we'll see coming up, it all comes down to turbidity, and then particularly in drinking water. So if it's very light and fluffy, the danger is you stir it up, you create turbidity in the water, and often these tanks are live. That's why we're doing the underwater water. Actually, in this video, you can see that there's air coming in the back there. That tank was live, and there was air coming into the inlet, little bubbles coming through the inlet. And this sand is quite heavy, and we've had sand up to 1 meter deep, which we've been able to pull out, because as you can see, it flows down towards the machine. But other times, if it's very, very light sediment, you've got to be incredibly careful, because you don't want to push into it. All the suction's happening underneath or at the very front of the machine if you push into a big high mound of light sediment, you could cause it to fly up and float away in the water, and then that's an issue obviously for a live tank. So it's a very much, it depends. And obviously here's a higher speed industrial where the stability wasn't an issue. So great, thanks for that one, Klaus. There's one particular question that's a bit of a recurring one actually, and it's also one of my bank questions I had up my sleeve ready to go, and it seems like it's been addressed here by a couple of people. One of the questions is there any scope for using the wall cleaner in potable water tanks? That obviously the one, this is referring to the nuclear option you showed where it was sticking to the steel wall. And then Alan has asked a similar question. The example of the vertical wall being cleaned showed a metal surface and lowered from the top. Would a concrete surface provide a smooth enough surface for suction? And are there alternatives for lowering, as was shown, considering access in most potable water tanks is obviously limited just to a hatch? So my question was very similar. What about wall cleaning? I'm sure you get asked that question as often as we do. What are your thoughts on that?
I get a lot of different views on wall cleaning, where they in some places say that do not touch the walls, they don't need to be cleaned, and they make a reference to at home where you normally don't vacuum the walls. And on some markets they say that it's a must, that it's not interesting with our products if we don't clean the walls. So I'm still a bit confused why it varies so much from different markets. But in all honesty, we don't have a lot of experience from cleaning the walls in drinking water reservoirs. And I would say that if it's if sort of the wall is flat enough, the machine will suck itself onto the wall, even if it's a concrete wall. But you have to find a way of sort of placing the machine on the wall. So I think it's an area that we would need to explore a little bit more before I could promise that we can do the job. Another aspect to this is, though, that in some places they told me that the sediment itself does not really stick on the wall, but the sediment that is on the wall actually comes from the surface when the water goes up and down. And they say maybe it would make more sense to have a cleaner that would keep the surface clean. And that is something we're looking into. But of course, that's a completely different cleaner than the ones we have shown today.
Yeah, and I think the other key thing there is, and you touched on it, is that these machines are generally removing sediment that can be lifted under a flow of water effectively by creating a vacuum with a pump. And that's fine because the sediment drops out of the water in a surface reservoir and sits on the floor. That sediment generally isn't sticking to walls. What you're getting on the walls is a biofouling effect. The biofoul kind of matrix that is on there. Sometimes you see it really as a stain when the tank is empty. And obviously at Panther McLeod, we clean that with our PM chemicals, and that effectively does a biological kind of melting action on that biofouling and pulls it off. So if we were going to be cleaning walls with a robot, it's more than just a suction of sediment that we're needing to look at here. You start to complicate it by having to become a chemical clean effectively, because high pressure sometimes in a drain down tank generally doesn't remove that either. So mixing chemical cleaning in a robot on a wall in a live tank is starting to really complicate things to the extent that we don't necessarily have an answer for that, unfortunately, just yet. Moving on just with time, we've got a question here from Louis. Sorry, I don't know if I pronounced your name wrong. Is this system to removing crustaceans apart from loose sediments? What I'd ask, can you just post again in there with an example perhaps of what you're talking to, and we'll come back to that question. What kind of environment are you talking about for incrustations? Is that potentially on perhaps inlet pipes and things like that? But if you can just clarify that question, we'll come back to that. There's a question on the chat box, Klaus, about pump head height on the cleaners, and I actually have got a question myself, and as a bank question around. Can you just touch briefly on the flow rates for your pumps, the pressures that are involved, the kind of head heights that you can achieve, what kind of the general standards? And I think we're probably talking about a VR600 here in a potable water scenario again, just to limit the question.
Yeah, when we talk about the VR600, in the VR600 we have a standard pump of 2.3 kilowatt, and we say it gives about 1,200 liters per minute at the discharge point on the machine, and we talk about 12 to 15 meter head. And I think one thing, I don't know for sure if we define the head exactly the same, because it's different in different parts of the world, but the head for us is the distance from the water surface to the discharge point. So we have found that we have yet to find a drinking water reservoir, I think, where the head from the VR600 is not enough. Also, in some places where we have been, where there has been a high head, also if you have the discharge hose coming out of the reservoir and dropping down on the outside, sometimes you get what is the English expression? A siphon, right? So you get a flow, and the problem is sometimes even it's a different problem, because when you turn off the pump, the flow keeps coming. So you need to have some sort of a non-return valve just to secure that you can actually stop the flow. So it's again I would say in drinking water reservoir, the head of the VR600 is very seldom a problem. And of course, if you for some reason want to pump maybe for a longer distance, it's very simple to add a booster pump of any kind on the outside of the reservoir.
So that's great question, and so thanks for the answer there. And I'm going to link that to just what you just said, Klaus, to another one of the questions, which is about distance, and it's very much a kind of a segue to the final part of that answer. Michaela, I think from Southeast Water, if I remember correctly, has asked us here, how far can it travel from the point of entry into the tank? If the tank has baffled walls, would you have to have multiple points of entry? And we got a great example of a job exactly with that problem from a couple of years ago, which I can mention, but I'll throw that over to you, Klaus. How far from the point of entry, how far can the cleaner generally go?
Oh, how far from the entry? The farthest we have gone into a reservoir is about 200 meters, and still pumping without any help of a booster pump. But that is as far as we can get. If we go longer, we have to have a look at the electrical issues because of the power drop along the cables and all that. I would say that is probably more of a concern than the discharging. So that's about it, 200 meters.
Yeah, and that's very similar to our experience, and 200 would be really, I think, pushing it, because the amount of equipment, cabling, the control element of passing the signal over that distance, all of these things start to become factors from our experience. We had a superb example of a job where that was the problem. There was actually large amounts of awards handed out for various contractors, so we're very proud of our part. I think it was around about 2012, 2013, Horsley Water Treatment Works in Northumbrian Water, which feeds half of Newcastle, had a contact tank. I think it was about 40 megaliters off the top of my head. That had a number of baffle walls in it, but then it had a single point of entry, and the route to the whole tank. And I think some of the footage I showed you there with that white lime and sand mix at very high levels came from that particular job. And we could get into the entrance. We could do the first channel and around the first wall, but we had trouble getting around the second and third turn effectively in the baffle walls, and we couldn't get to the far end. And in that particular job, unfortunately, it was a bigger project. That tank hadn't been cleaned for 40 years. They really had to do something with it. They couldn't take it out of supply. And new hatches were cut at the far end of the tank in a live scenario, and we used our ROVs to look at that from underneath and help with the whole health and safety and issues arising from anything falling in. We worked with other contractors. They cut holes. We created new hatches while we were working on it, and then we were able to access it from the other end. So I guess multiple entry points on something like that, Michaela, is ultimately the answer as things stand.
Of course, that
Lewis has come back. Is the system able to remove incrustations built up in reservoirs, e.g. due to hard water as similar water as a similar way as water tuberculation in pipes. So yeah, we're talking about metalwork, I guess, coming in to service reservoirs, inlet pipes, outlet pipes, scours, railings, anything like that. Do you have anything? We don't do anything like that, Klaus. Have you got any answer on what to be done with that?
Don't forget that I'm Swedish. I'm not sure I understood this to 100%, but if we talk about cleaning reservoirs where there are larger particles, is that
So yeah, it's building up. It's building up incrustations that have built up on metalwork. We don't do that. I don't know if you've got any industrial options to do that.
Sorry, explain to me incrustations. Is that like corrosion, or is that?
Yes.
Yeah.
Yeah. If other people had microphones, I'm sure I'd get help here. But yeah, corrosion and the buildup of corrosion and incrustations.
No, I would say that, yeah, I mean, removing any sort of, I mean, we have done tanks, we have done steel tanks, of course, where there has been corrosion on the floor, and we can use different type of brushes. And I don't know if you noticed, but on the machine that we have made for the reactor tanks for the nuclear power stations, we use more. We don't use like a nylon brush. We use a kind of a Scotch-Brite instead. So I mean, we can switch and adapt to different type of brush systems depending a little bit on what you need to remove.
Okay.
If that answers the question.
Yeah, I think it does. I think at the moment, getting back up off the floor, it's similar to the walls in a drinking water asset. That's not something that's achievable right now. And I guess if the demand and need is there, is something that we would look to work with Weeder on, but unfortunately we can't address that at the moment. I'm conscious
I would say this, Jamie. I'm sorry for interrupting, but I would say this, that we have learned over the years for all types of markets that we go into, that before we answer questions, we try to find out to 100%, of course, what the problem is, and we have learned very in the beginning through experience that if we are not sure, we are very clear with the client that there are reservoirs and there are applications where we do not have a solution. And if we find that out, then we are very honest and we say so from the beginning. That saves everybody a lot of trouble. So we would be very happy if you have clients, Jim, in the UK, or somebody listening that has some sort of a special situation, a little bit different to what we have talked about. We'd be very happy to discuss that together with you and see what we can do.
So a couple more questions, Klaus, and we can hopefully get all the questions. We reached pretty much the end of the time of the 45 minutes we hope to do this in. So quite quickly here, Alan's asking, is there a maximum gradient for floor cleaning with the current cleaners?
Yes, and that depends a little bit on the bottom surface. But for a regular concrete floor, you have experience from this also, Jim. We normally agree to your question. I lost you.
Yeah, sorry, I think we lost you as well, Klaus. Do you want to just try that?
Okay. Yeah. We from experience, it depends, of course, a little bit on the flooring, but we normally say okay when it's around 20 to 25 degrees is what the VR600 can do normally.
Right. Okay.
Yeah.
I mean, you make a good point about it. The different type of surfaces. What we tend to do, and you will have seen in the pictures that we've shown of the machines, rather than me pulling it up again at this late stage, the tracks that run around have got little nodules and they're all placed individually, and we can change that material from a harder kind of plastic to a kind of more rubberized plastic if we're looking to do a bit more of a gradient. I guess in a water tower, for example, Klaus, you showed earlier on in your presentation a water tower with a bowl effectively affected the top of the tower, a US style kind of ball on a T. You would, based on the material that you're working on, you can change the track to get a bit more traction and a bit more grip.
Exactly. Yeah.
The compromise between the pumping power and speed and also the gradient and the material.
And I tell you, with that type of reservoirs, also 99% of the sediment is on the bottom.
Yeah, it's at the bottom.
So
of the
you
book.
really don't have to go all that far up on the walls normally.
Yeah, good. Final question, Klaus. This is about placing the wall cleaner. Can we place the wall cleaner with another ROV? So this is a great idea. I'm not sure that technically it's achievable because of the weights involved, but you can see in the background behind me, Helen here is asking. We've got a video where one of these mixers, a smaller version of that actually from another one of our partners, was positioned with an ROV. That mixer, and it's not the one in the picture here on the wall, has a bulb in it with an air flotation in it that's designed to keep the mixer upright. It makes it very light in water, only about 8 pounds. So moving it with one of our ROVs is reasonably easy. Unfortunately, the weights of these machines that we're using for the cleaning, they're designed to be stable and stick in one place because obviously they become lighter underwater. So we still need a good amount of weight in there to hold them in place and on track and to be controllable, which means that moving them around with another ROV would need a lot of power, a lot of force to do that. So do you have any comments on that, Klaus?
Yeah, I do actually. It's an excellent idea maybe to push the machine with an ROV. I don't know if I was clear enough, but the cleaner again for the reactor tanks has a floating cover on it. So when you drop it into the water, it actually floats. And I mean, with those floats, we can make the machine weigh anything. I mean, we can make it even float a little bit under the surface. And in some places, then when you start the pump works a little bit like a propeller, meaning that it moves. You can actually get it to move towards the walls. And if you can sort of control it a little bit extra with an ROV, it may be an excellent idea. I thought I knew everything, but I don't.
Helen,
I think, Jim, this is something that we should try. And maybe you saw on the pool cleaners that they all had some sort of a cover. And the reason for flotation and those machines, they are made so that when you drive it over the edge in a pool, it falls very slowly down and sits on the bottom. And again, we can change that floating cover, and we can put a similar floating cover, Jim, onto a VR600.
Yeah, that's interesting. It raises another quick thing, and we'll just wrap up with this. But we have looked at flotation devices you can activate, a bit like rescue rafts or things like that for recovery. Because sometimes the machine breaks down, it's a long way from the hatch, and you've got to put a lot of pressure on the cables to pull it out. We've talked about the option of having a flotation device that could be activated at that point to reduce the weight, so it could be pulled easier. But I think Helen's onto something here, and maybe offline, Helen, we can talk to you about a trial and get Klaus engaged in seeing how we can get some flotation and ROVs to work together to maybe do some walking. Notwithstanding, we need to work out what it is we're actually cleaning off the walls, because there's not a huge amount of sediment there. So that's back to that previous point.
That's an excellent idea. Thank you very much, Helen.
So Klaus, we've run over slightly. That's because the questions were great. The engagement's been brilliant. And thank you very much for all your patience in the last couple of weeks as we've been setting this up. And thanks very much to the attendees for joining us. We're going to do a recorded version of this. We're going to cut out any of the unnecessary flannel, make it slightly shorter, and we post it on our website as a recording that you can look at again, or you can send on to other people. But thanks, Klaus, again to you for all your effort with this. And thank you to all the attendees. Great to have you on board. Some brilliant questions there. And please get in touch with us if you have anything else that you want to talk about on this whole thing.
Thank you. Thank you very much.
On that note, I think I can hear my lunch calling, and I'm going to end the meeting for all of us. And thanks again to all of you for joining in. All the best. Bye-bye then.
Thank you very much. Bye now.